Hello! Now we are going to find missing angles and sides for right triangles using our trig functions. So for starters, let us take a look at this triangle right here. We've got two sides and we've got one angle that's denoted by theta. We need to figure out what theta is. In order to do that, because this is a right triangle, we can use our good old trig functions, SOHCAHTOA and all that. So step one, first identify what sides are which in your triangle. What's the 42? That should be your hypotenuse. That is a backwards P. There we go, hypotenuse. Go across from your theta. This is your opposite side, right? And then this 24, well, that's just going to be your adjacent. Whoop. You know, it's your adjacent because it forms this theta. So we've got the hypotenuse, we've got the adjacent. Let's work with those two, because that's what we've got. So adjacent hypotenuse, SOHCAHTOA. Which of our functions here will help with that? Let's focus on just sine, cosine, and tangent, because those are the ones that we can use most easily on our calculators. We've got adjacent, we've got hypotenuse. That sounds to me like adjacent hypotenuse. That's cosine. Remember, cosine of theta is your adjacent over your hypotenuse. So let's go ahead and set cosine of theta equal to your adjacent, which is 24, over your hypotenuse, which is 42. Now, we want to get theta by itself. So what we're going to need to do is we need to take the inverse cosine of both sides. I'm just writing this all out here just so you can see it. This is going to equal the inverse cosine of 24 over 42. Because this will allow us just to get theta equal to the inverse cosine of 24 over 42. And this can go right into our calculator. Get the low battery warning. Hit second cosine to get the inverse cosine. We're going to do 24 divided by 42. Close your parentheses. 55.15. We're going to round that to the nearest tenth, so that rounds to 55.2. And that's our answer. That's our theta, 55.2 degrees. I want you to try one. First of all, what are our sides? This should be our hypotenuse, right? Because it's across from the right angle. There's our theta. So this is going to be the opposite. And then this will be our adjacent. We've got the opposite, we've got the adjacent. SOHCAHTOA. Tangent is opposite and adjacent. Tangent of theta is opposite over adjacent. So we plug in tangent of this theta that we are looking for is equal to our opposite, which is 12, over our adjacent, which is 9, we're going to have theta, again, like we saw before, it's the inverse tangent, because we want to get this tangent out of there. So we're going to take the inverse tangent of 12 over 9, plug that into our calculator, second tangent, so we've got the inverse, the negative 1 up there, 12 divided by 9, close your parentheses, we'll get theta equal to 53.1 degrees. And that's it. That's done. Let's go on to finding missing sides. So we're going to use pretty much the same way that we did before, but we're going to be solving for a different piece of the puzzle this time. This time we've got the angle, but we've got two sides that we're interested in. So let's identify all of our sides. This is the hypotenuse, and as you can see, we've got nothing for it, so we're really not going to be using it much. If this is my angle, I want to go across from that at this 17. That is going to be my opposite. And then that leaves this to be, the x is your adjacent. We're working with opposite and adjacent. Well, we've got tangent again. So the tangent of, this time we've got the angle, so we're going to plug in for the angle. We've got 20 degrees, we're going to take the tangent of 20. So the tangent of 20 is equal to our opposite over adjacent. That puts 17 up top, and our adjacent on the bottom. Now this becomes an old school algebra problem. How do we solve it? What's the first thing we should do? We want to solve for x. We need to get x by itself, so the first thing we need to do is get it out of that denominator. We're dividing by x. Let's multiply by x so that it cancels out on this side, and we're left with x times the tangent of 20 equals 17. We're almost done. Now we need to get x by itself. Tangent of 20 is a number. It's a fairly small number, but we can divide by it. We want to get rid of it, so we want to divide on both sides to keep it equal. Divide by tangent of 20, divide this side by the tangent of 20. These cancel out, so you're left with x equals 17 over the tangent of 20. Put that into your calculator. 17 divided by your tangent of 20. Notice also we're not doing inverse tangent now. This is just regular tangent. Okay, we don't need to use inverse tangent here. Put that in, and we get 46.7. X equals 46.7. That's it. That's the length of our side. Let's try one more that I want you to take the lead on here. What are our sides? Which is which? Hypotenuse, right? And this? This would be your opposite. And then we've got the adjacent over here. So we're working with the hypotenuse, which we know, and we want to know the opposite. So we're going to be looking for a trig function that's got the opposite and the hypotenuse. What have we got? So, right? SOHCAHTOA. Sine is opposite over hypotenuse. So we're going to set the sine. Again, they give us the angle here. We're finding a side, so they give us the angle. We're going to plug in the angle. Sine of 40 equals our opposite, which is x, over the hypotenuse, 12. Next step, get out that 12. We got to do it on both sides to keep it even. Cancels out over here. We're left with x equaling 12 times the sine of 40, and that's pretty much it. We can plug that into our calculator. Save putting everything into your calculator for the end, if possible. 12 times the sine of 40 makes it a lot easier. If you start plugging stuff in too early, then it becomes a big mess. So we're left with 7.7 for x. And that's it. We solve for the sine. The trick to working with these, when you're finding the missing angle or missing side, figure out which sides you've got so you can figure out which trig function is the best one to use, which ratio. It is going to be a little bit different each time. Sometimes cosine or sine or tangent will be easier to work with. Look at what you've got, label each side, take an inventory, and then you can figure out which one you're going to want to use. Set up the equation. Once the equation is set up, really the hard work is out of the way. At that point, it becomes an old school algebra problem, which I'm confident you will have no trouble with. Keep practicing at it, and I'm sure you will do awesome.